In this video, we'll take a look at working with TensorFlow and Keras. Start off by looking at what is TensorFlow, and then evaluate the fundamental data types in TensorFlow, the tensor and the variable. And then we'll take a look at Keras and revisit logistic regression with Keras and reinforce higher-level machine learning library benefits. So TensorFlow is a library for math and deep learning with symbolic interfaces. It's got automatic differentiation, predefined layers, GPU, TPU, which is a proprietary Google tensor processing unit, and distributed computation are all built in. So let's take a look at TensorFlow. It really is all about tensors and multidimensional arrays. At the basic level, you build up a computational graph of tensors, and then you run them in a session and push values through them. There isn't an imperative step-by-step feel like NumPy or MXNet, so this is always symbolic math. There's graphs of operations every time and the numbers flow through, so the name TensorFlow is a pretty good description of what's going on. So we'll start off by making a couple of constants here, and then we'll add them and get a total. And you can actually see that it just comes out with a shape, but not any actual values. So in order to get the math to happen, in order for there to actually be the addition, we have to create a session and we have to run it. And then finally you can see we get the 4 and the 6. So that's pretty good for just constants. But now let's set up a graph where we have some real parameter values, so you can call it like a function. That's what you use placeholder for. And then the feed dictionary feeds in the x and the y values. So we'll have a 1 and a 2, and a 1 and a 3, and a 2, 4, and then you can see them add together, and so 1 plus 2 is 3, and the 1, 3, 2, 4 added together are 3 and 7. And that's it. You can pass in different shapes and different numbers, but you have to run it in a session for the math to happen. Now the next major thing you do in TensorFlow is the variable. Now while placeholders can take values from outside of the graph, variables are updated by the graph running. This is what the optimizer does when it's actually learning, is it learns the variable values and changes them until we get the best fit. So we're going to define variables u, v, and w, and have them a shape of 2 by 2, and then we're going to have zeros initializers. We're going to have zeros, and then we're going to have 0 plus 1, which is going to be 1s, and 0 plus 2, which is going to be 2s. And then we're going to build a placeholder so we can make a graph. So x is going to flow over there, and you can see our formula is y equals v times x plus w. So the variables need to be initialized, and this is like a global reset. It gives you the brand new variable values and throws away any old values. And we're going to feed in 1, 2, 3, 4 and run the session. Now, that's not super exciting. You can actually see what's going on, and now we can apply tensors and variables based on what we learn here in order to build them up a little bit more in order to do logistic regression. So this is really just the raw way to deal with TensorFlow. It's not likely that you'll need to do this very often. Much more likely to do is to use Keras. So your deep network, which is your model that you're going to build, layers on top of Keras, which gives you a nice symbolic interface in order to build up layered networks. And then it, in turn, calls TensorFlow for you. It allocates the variables and initializers, it sets up the tensors, and it runs the session and graph all automatically so you don't have to. All right, so let's take a look. Now we can create a simple logistic regression model with TensorFlow directly, and then we'll actually compare that. So we'll bring in TensorFlow, we'll actually use the MNIST digits, and then read those data sets in. Now remember, we implemented logistic regression before with Keras, and it was pretty simple. This is going to be a little bit more involved. Same kind of thing of the number of parameters we've been looking at in the last couple of videos. Now for inputs, we need to create 2 placeholders. We have a placeholder for the x and the y. So the x is going to hold the images, the 28 by 28 images, and the y are going to hold the classes. So we have the number of outputs, so there's 10 output classes. And then we're going to learn certain variables in order to build the logistic regression model. So we have a w, a weight matrix, and a bias, and that's the actual model. So w and b are what we're going to be learning. And the formula is pretty simple. We multiply x, which is our images by the weights, and add the bias, and then we run softmax over that. So it's just one layer to make our predictions. We then do cross entropy loss on our own, reducing the mean. So what this is really doing is actually computing the softmax cross entropy loss. This is the actual math formula to get it done. And then we actually take that loss and feed it into the gradient descent optimizer. So we have our learning rate, which is a parameter we control, and we feed the loss in and it optimizes. We initialize all the variables in order to get the model started. And again, in raw TensorFlow, you're going to be building your own training loop. Now compared to MXNet, you'll notice the backward propagation and the computation of the loss is somewhat more automatic. You just have to tell the session to run with the optimizer and the loss function. The way I like to think about this is the session pulls data from the feed batch through to the loss function, which pulls on the model, here via pred, which are the predicates we compute, which pulls on x and y. So it actually flows the data through the set of tensors, hence the name TensorFlow. And then we print the output data here. You can actually see for each epoch, we look at the cost, which is the loss result coming down, and the accuracy coming up. So good old logistic regression. But it is quite a bit more code than the version we saw in Keras that we worked on before. And this really should reinforce to you that TensorFlow as a raw user interface is something you're very rarely going to want to use as an engineer. It's just interesting to know what's going on under the hood. Now in the next video, we'll define and train neural networks in Keras and TensorFlow using the Keras library.